The moment Marcus told me I couldn't handle pressure, I was staring at my screen showing bug ticket 847 marked as resolved. 3 months of systematic debugging, each fix documented with surgical precision, and he chose that exact moment to question my capabilities. The irony wasn't lost on me, though I suspect it was entirely lost on him. I had been expecting this conversation for weeks. The signs were all there: the sideways glances during stand-up meetings, the subtle exclusion from planning sessions, the way he would assign the high-visibility projects to newer team members while I continued working through the technical debt that kept our systems operational. Marcus had made his decision about my future with the company long before he called me into that sterile conference room. The fluorescent lights hummed overhead as he delivered what he clearly thought was devastating news. My inability to thrive under pressure, he explained, was holding back the entire development team. The company needed people who could innovate quickly, not someone who got bogged down in the minutiae of legacy code maintenance. He spoke with the confidence of someone who had never spent a weekend debugging a memory leak that was crashing production servers. I nodded thoughtfully while he spoke, already calculating my next moves. The 847 critical bugs I had resolved over the past 3 months represented more than just fixes. They were a comprehensive audit of every system vulnerability that could potentially bring down our infrastructure. Each ticket told a story of underlying architectural problems, security flaws, and performance bottlenecks that had been accumulating for years. But Marcus saw only the numbers: 847 tickets closed, no flashy new features delivered. What he didn't understand was that those bugs weren't just isolated problems. They were symptoms of deeper systemic issues that I had been quietly documenting and resolving. Every fix had been carefully prioritized based on potential impact, system dependencies, and long-term stability concerns. While other developers chased the glory of building new functionality, I had been ensuring that the existing functionality would continue to work. The pressure comment particularly amused me because handling pressure had defined my entire career. I had joined this company 5 years earlier as a mid-level developer, drawn by their reputation for technical innovation. What I found instead was a sprawling codebase held together by hope and caffeine, with critical systems that hadn't been properly maintained in years. While my colleagues complained about the technical debt, I saw an opportunity to build something sustainable. Those first months were a masterclass in pressure management. Production incidents occurred almost daily, each one requiring immediate attention, while simultaneously working on whatever feature was deemed urgent that week. I developed a systematic approach: triage based on user impact, implement temporary fixes to restore service, then circle back during quieter periods to address root causes. It wasn't glamorous work, but it kept the lights on. Marcus had arrived 18 months ago as our new team lead, brought in specifically to modernize our development practices. He came from a startup background where rapid iteration and feature velocity were paramount. His first team meeting set the tone for everything that followed. We needed to move faster, ship more features, and stop getting bogged down in perfectionism. Technical debt, he assured us, was just another word for procrastination. I had tried to explain the situation during our early one-on-one meetings. The codebase had accumulated years of shortcuts and temporary solutions that had become permanent. Critical systems were running on deprecated technologies with known security vulnerabilities. The bug backlog wasn't just a list of minor annoyances. It contained fundamental issues that could compromise data integrity or system availability. But Marcus had his own vision for the team's direction. His strategy was simple: assign the most experienced developers to greenfield projects, while newer team members handled maintenance work. This would maximize innovation while minimizing the time spent on legacy issues. When I pointed out that many of the bugs required deep system knowledge to resolve safely, he suggested that maintaining legacy code was exactly the kind of work that prevented senior developers from reaching their full potential. That conversation marked the beginning of my strategic realignment. If Marcus wanted to view bug fixes as beneath my skill level, I would demonstrate exactly what senior-level debugging looked like. I began approaching each ticket not just as a problem to solve, but as an opportunity to improve overall system reliability. Simple fixes became comprehensive solutions that prevented entire categories of future issues. The work itself was intellectually satisfying in ways that Marcus couldn't appreciate. Bug 234, for example, appeared to be a straightforward null pointer exception in our user authentication service. But tracing through the code revealed a race condition that occurred when multiple login attempts happened simultaneously. The fix required implementing proper synchronization mechanisms and updating our database schema to handle concurrent access patterns. What Marcus saw as one resolved ticket actually prevented dozens of potential security incidents. By month 2 of my systematic debugging campaign, patterns were emerging that painted a concerning picture of our infrastructure health. The bugs weren't randomly distributed across our systems. They clustered around specific integration points and data processing pipelines. Several critical services were operating far outside their intended parameters, held together by exception handling that masked underlying performance problems. I began documenting these patterns in a private repository, creating a comprehensive map of our system dependencies and failure modes. Each bug fix became a data point in a larger analysis of structural weaknesses. While my teammates rushed to deliver new features, I was quietly building a blueprint for sustainable system architecture. The documentation grew into something approaching a technical audit. I identified 17 critical services that were running on unsupported software versions, 12 integration points with single points of failure, and 38 security vulnerabilities ranging from minor information disclosure to potential remote code execution. The 847 bugs I was fixing weren't isolated problems. They were visible symptoms of a system in crisis. Marcus remained oblivious to the scope of what I was accomplishing. During team retrospectives, he would highlight the new features delivered that sprint, while glossing over bug fixes as necessary but unremarkable maintenance work. When stakeholders asked about system stability improvements, he credited the overall team effort rather than acknowledging the systematic work being done to address root causes. This disconnect became particularly apparent during our quarterly planning sessions. Marcus would present ambitious roadmaps focused on user-facing features and new product capabilities. When engineering managers raised concerns about technical debt, he had prepared responses about the importance of maintaining development velocity and not getting trapped in endless refactoring cycles. The 847 critical bugs I had resolved were dismissed as routine maintenance that any competent developer could handle. I found this perspective fascinating from a risk management standpoint. Marcus was essentially betting the company's technical future on the assumption that fundamental infrastructure problems would resolve themselves through benign neglect. Every new feature added complexity to systems that were already straining under their current load. Each sprint delivered functionality that depended on the same fragile foundations I was quietly reinforcing. The third month brought an acceleration in both bug complexity and stakeholder frustration. Customer support was reporting unusual system behaviors that didn't fit standard troubleshooting protocols. Sales demos were failing in unpredictable ways. The executive team was asking pointed questions about platform reliability that Marcus struggled to answer convincingly. I knew exactly what was happening because I had been tracking the interconnected failures for months. Our authentication service, which handled login requests for all customer-facing applications, was experiencing cascading performance degradation. The symptoms appeared random because they emerged from complex interactions between multiple system components, each operating slightly outside their optimal parameters. The authentication issues alone involved 14 separate bugs spanning database query optimization, session management, cache invalidation, and load balancing configuration. Resolving them required understanding not just individual component behavior, but the intricate timing relationships that emerged under production load conditions. It was exactly the kind of systematic debugging work that Marcus considered an inefficient use of senior developer time. While I methodically worked through each component of the authentication pipeline, Marcus grew increasingly frustrated with what he perceived as my slow progress on feature development. He began assigning my planned work to other team members, explaining that we needed developers who could deliver results quickly rather than getting lost in technical rabbit holes. This redistribution of assignments created an interesting natural experiment in development approaches. The features I had been planning were reassigned to developers who shared Marcus's philosophy of rapid iteration and minimal technical debt consideration. Meanwhile, I continued working through the infrastructure issues that were causing daily customer impact. The results spoke for themselves within weeks. The hastily implemented features required constant hotfixes and generated new bug reports faster than they could be resolved. Customer-facing functionality became increasingly unreliable as new code interacted unpredictably with existing system components. Marcus found himself spending more time in crisis meetings than strategic planning sessions. During this period, I received my first inquiry from a technical recruiter. The message was unremarkable: a senior engineering position at a company building infrastructure solutions for enterprise clients. The role required deep expertise in system debugging, performance optimization, and technical debt management. I responded with polite interest, mentioning that I might be open to exploring new opportunities. The initial conversation with their technical team was refreshingly different from my current work environment. They asked detailed questions about my approach to complex system problems, my experience with legacy code modernization, and my strategies for maintaining system reliability under changing requirements. When I described the systematic debugging work I had been doing, they wanted to understand not just what I had accomplished, but how I had approached the problem-solving process. Their technical challenges were fascinating. They were building developer tools that needed to integrate with dozens of different programming languages, frameworks, and deployment environments. Reliability was paramount because their customers used these tools in production environments where downtime meant lost revenue. They needed someone who could think systematically about failure modes and build resilient solutions from the ground up. The interview process stretched over several weeks, involving technical discussions with their engineering leadership, architecture reviews with their systems team, and cultural conversations with potential colleagues. Each interaction reinforced my sense that this was an organization that valued the kind of deep technical work I had been doing. Meanwhile, the situation at my current company was deteriorating rapidly. The authentication issues I had been systematically addressing were now causing daily customer complaints. Marcus was fielding increasingly urgent requests from the executive team for status updates and timeline estimates. The features his team had rushed to deliver were generating support tickets faster than they could be triaged. I had reached bug ticket 801 in my systematic debugging campaign when Marcus called the meeting that would define our professional relationship. He had clearly been building up to this conversation for weeks, gathering evidence and preparing arguments for why my approach to software development was fundamentally misaligned with company needs. His presentation was thorough and professionally delivered. He had compiled metrics showing that other developers were delivering features at twice my rate. He had gathered feedback from stakeholders who were frustrated with the slow pace of visible progress on user-facing functionality. He had prepared a development philosophy framework that emphasized rapid iteration, customer feedback, and market responsiveness over technical perfectionism. The irony was exquisite. While Marcus presented his case for why I couldn't handle the pressure of modern software development, I was simultaneously managing the resolution of system-critical issues that his preferred development approach had created. Bug 802 was a data corruption issue that emerged when new feature code interacted with existing database schemas in unexpected ways. Bug 803 was a memory leak caused by improper resource cleanup in hastily implemented API endpoints. As Marcus explained why my focus on bug fixes demonstrated an inability to prioritize high-impact work, I was calculating the potential blast radius of the 17 critical vulnerabilities I had identified but not yet had time to address. Each represented a possible path to complete system compromise, ranging from data breaches to service outages that could affect thousands of customers. His conclusion was predictable and, from his perspective, entirely logical. The company needed developers who could balance technical excellence with business pragmatism. My fixation on resolving every possible system issue, while admirable from a craftsmanship standpoint, was preventing the team from delivering the innovation that customers were demanding. I listened without argument, occasionally nodding to acknowledge his points. There was no benefit to explaining why his analysis was fundamentally flawed. Marcus had already decided that technical debt was a luxury the company couldn't afford, and no amount of evidence about system reliability would change his strategic priorities. When he finished presenting his assessment, I confirmed my understanding of his concerns and thanked him for the feedback. The conversation that would normally involve defensive explanations or improvement commitments instead became a brief discussion of transition timelines and knowledge transfer responsibilities. Marcus seemed surprised by my composed response. I suspect he had prepared for pushback, defensiveness, or attempts to negotiate alternative arrangements. Instead, I approached the transition as a professional project with clearly defined objectives and deliverables. The knowledge transfer process became an interesting exercise in documentation and communication. Marcus wanted comprehensive handoffs for all ongoing work, detailed explanations of system architecture decisions, and thorough documentation of debugging methodologies. Essentially, he was asking me to create a manual for performing the technical debt management work that he had just determined was outside my capabilities. I approached this documentation project with the same systematic thoroughness I brought to debugging. Each document included not just procedural instructions, but contextual analysis of why specific approaches were necessary. I documented the relationships between seemingly unrelated system components, the historical decisions that had led to current architectural constraints, and the potential consequences of various maintenance strategies. The documentation grew into a comprehensive technical guide that spanned hundreds of pages. It included detailed analysis of the 847 bugs I had resolved, categorized by system component, root cause, and potential for future recurrence. I documented the 17 critical security vulnerabilities with step-by-step remediation procedures and impact assessments. I created architectural diagrams showing system dependencies and failure modes that weren't obvious from examining individual components. During this documentation phase, my conversations with the potential new employer continued to progress positively. Their technical team was impressed with my systematic approach to complex problem-solving. Their engineering leadership appreciated my focus on long-term system reliability over short-term feature velocity. Their executive team understood that building developer tools required exactly the kind of deep technical expertise I had been developing. The offer, when it came, was substantially better than my current compensation. But more importantly, it represented an opportunity to work with an organization that valued technical depth and systematic thinking. Their problems were complex and interesting, their team was technically sophisticated, and their business model rewarded reliability over rapid iteration. I scheduled a meeting with Marcus to discuss my resignation, bringing printed copies of the transition documentation and a proposed timeline for knowledge transfer activities. The conversation was brief and professional. I explained that I had accepted a position that better aligned with my professional interests and thanked him for the learning opportunities our collaboration had provided. Marcus seemed genuinely surprised by the timing. He had apparently expected that our previous conversation would lead to a performance improvement period rather than an immediate job search. When he asked about my new role, I described it in general terms: senior engineering position, infrastructure focus, emphasis on system reliability, and debugging expertise. His reaction was gratifying in its predictability. He questioned whether jumping to a new company was really the best career move, particularly given the performance concerns he had raised. He suggested that my debugging skills, while technically impressive, might not translate well to the broader responsibilities required in senior engineering roles. He wondered aloud whether a company that valued debugging over innovation was really where I wanted to build my long-term career. I thanked him for his concerns and assured him that I had carefully considered the opportunity from multiple angles. The 2-week notice period would provide adequate time for comprehensive knowledge transfer, and I was committed to ensuring a smooth transition for all ongoing projects. The 2 weeks that followed were professionally satisfying in unexpected ways. Word of my resignation spread quickly through the engineering team, prompting conversations with colleagues who had been observing the systematic debugging work I had been doing. Several team members asked detailed questions about specific bugs I had resolved, finally understanding the scope and complexity of the issues I had been addressing. These conversations revealed that many of my colleagues had been dealing with related system problems, but hadn't recognized the connections between seemingly isolated incidents. My documentation provided context that allowed them to understand why certain bugs kept recurring and how my fixes had addressed underlying architectural issues rather than just surface symptoms. The authentication service issues that had been plaguing the company for months suddenly made sense when viewed through the lens of systematic analysis. The seemingly random failures were actually predictable outcomes of specific load conditions interacting with suboptimal configuration choices. The fixes I had implemented weren't just resolving individual bugs, they were stabilizing an entire critical system. During my final week, Marcus began asking increasingly detailed questions about the technical debt documentation I had prepared. He wanted to understand which issues required immediate attention, which could be deferred safely, and which represented potential security risks. The conversation that started with him dismissing technical debt as procrastination evolved into urgent requests for prioritization frameworks and risk assessment methodologies. I provided comprehensive answers to all his questions, maintaining the same professional approach I had used throughout our working relationship. The documentation was thorough and well organized. Any competent developer should be able to follow the procedures I had outlined. Whether the team would actually prioritize technical debt management over feature development remained to be seen. My last day coincided with the completion of Bug Ticket 847, a complex performance optimization that had taken 3 weeks to resolve properly. The issue involved database query patterns that became inefficient as data volumes grew, requiring careful analysis of indexing strategies and query execution plans. The fix improved system response times by 40% while reducing server resource consumption. As I packed up my desk, Marcus stopped by to thank me for the thorough transition documentation and to wish me well in my new role. The conversation was cordial and professional, with no reference to our previous disagreement about pressure handling or technical priorities. He seemed genuinely interested in my new company and the types of problems I would be working on. I started my new position the following Monday, joining a technical team that immediately appreciated both my systematic approach and my depth of debugging experience. The onboarding process focused on understanding their architecture patterns, development methodologies, and quality standards. Their systems were well designed and properly maintained, but they faced complex integration challenges that required exactly the kind of analytical thinking I had been developing. The work was engaging and intellectually stimulating in ways I had forgotten were possible. Rather than fighting to allocate time for technical debt management, I was working with colleagues who viewed system reliability as a fundamental requirement for business success. Rather than justifying the value of thorough debugging, I was collaborating with engineers who understood that sustainable software required careful attention to underlying quality issues. 3 months into my new role, I received an unexpected message from a former colleague at my previous company. The authentication service issues I had been working to resolve had evolved into a full-scale system crisis. The 17 critical vulnerabilities I had identified were now causing daily security incidents. Customer data had been compromised, service outages were becoming routine, and the executive team was demanding immediate explanations for why their technology platform was failing so dramatically. Marcus had apparently been tasked with leading the crisis response effort, working with external consultants to understand the scope of the infrastructure problems and develop remediation strategies. The consultants had recommended a systematic approach to identifying and resolving technical debt, starting with a comprehensive audit of system vulnerabilities and architectural weaknesses. My former colleague wanted to know whether I would be interested in a consulting engagement to help with the crisis response. The company was prepared to pay premium rates for expertise in systematic debugging and infrastructure stabilization. They needed someone who understood their codebase and could quickly identify the most critical issues requiring immediate attention. I politely declined the consulting opportunity, explaining that my current role required my full attention and that I was committed to my new team's success. But I did offer to provide guidance on interpreting the technical debt documentation I had prepared during my transition, if that would be helpful for their crisis response efforts. The situation at my former company continued to deteriorate over the following months. Industry publications began reporting on their reliability issues, customer churn accelerated, and their technical team turnover reached critical levels. Marcus left the company 6 months after my departure, accepting a position with a different organization where his rapid iteration philosophy might be better suited to their business requirements. The contrast with my current work environment was stark and gratifying. While my former colleagues struggled with the consequences of deferred technical debt, I was working on challenging problems with proper time allocation and resource support. The debugging skills that Marcus had viewed as evidence of my inability to handle pressure were precisely the capabilities that made me valuable to an organization building mission-critical developer tools. My new company's approach to system reliability was fundamentally different from what I had experienced previously. Technical debt wasn't something to be minimized or ignored. It was actively managed through systematic measurement and continuous improvement processes. Bug fixes weren't viewed as maintenance overhead. They were understood as essential investments in platform stability and customer trust. The professional vindication wasn't dramatic or instantaneous. There was no moment of obvious triumph, no confrontation where I proved my worth through superior technical knowledge. Instead, it emerged gradually through the sustained success of working in an environment that valued the same technical principles I had been advocating. The most satisfying aspect was the intellectual stimulation of working on genuinely complex problems with adequate time and resources to develop proper solutions. Rather than rushing to implement temporary fixes that would create future technical debt, I could design sustainable solutions that improved system reliability while adding new functionality. 6 months after starting my new role, I was promoted to senior principal engineer, with responsibilities that included technical architecture decisions and engineering methodology development. The promotion recognized not just my debugging expertise, but my ability to think systematically about complex technical challenges and develop sustainable approaches to system design. The role expansion allowed me to influence how the company approached technical debt management, quality assurance, and system reliability. I developed training programs for junior engineers on systematic debugging methodologies, created architectural review processes that prevented common categories of bugs, and established metrics for measuring technical debt accumulation and remediation. These initiatives were successful because they aligned with the company's fundamental values around building sustainable, reliable software. Rather than fighting to justify time spent on technical debt management, I was working with leadership that understood the business value of maintaining high-quality systems. A year after my departure, I learned through industry networks that my former company had eventually hired a team of consulting engineers to address their infrastructure crisis. The engagement lasted 8 months and cost substantially more than my entire annual compensation. The consultants used a systematic approach to technical debt remediation that was remarkably similar to the methodologies I had documented during my transition. The consulting team's final report identified the same critical vulnerabilities I had documented months earlier, recommended similar architectural improvements, and proposed the same systematic debugging approaches I had been using to address complex system issues. The primary difference was that external consultants were viewed as credible experts, while my identical recommendations had been dismissed as evidence of excessive technical perfectionism. Marcus's replacement as team lead adopted many of the technical debt management practices I had advocated, including systematic bug prioritization, comprehensive root cause analysis, and proactive system monitoring. The development team began allocating specific sprint capacity to technical debt reduction, treating it as essential work rather than optional maintenance. These changes led to measurable improvements in system reliability, customer satisfaction, and development team productivity. The crisis that had seemed inevitable to me became a catalyst for adopting sustainable development practices that should have been implemented years earlier. The professional lesson was clear and somewhat ironic. My systematic approach to technical problem-solving hadn't been wrong. It had simply been applied in an organizational context that didn't value systematic thinking. The same methodologies that were dismissed as evidence of poor pressure handling at my former company were recognized as valuable expertise at my current organization. 2 years into my new role, I was invited to speak at industry conferences about systematic approaches to technical debt management. The presentations focused on the business value of proactive debugging, the long-term costs of deferred system maintenance, and the organizational changes necessary to support sustainable development practices. These speaking opportunities led to additional consulting requests and advisory positions with other technology companies facing similar infrastructure challenges. The expertise that Marcus had viewed as narrow and limiting had become the foundation for a broader career in technical leadership and systems architecture. The broader professional vindication came through recognition from the engineering community rather than any direct confrontation with my former manager. Industry peers began seeking my input on complex debugging challenges, architectural decisions, and technical debt management strategies. The systematic thinking that had been undervalued in one organizational context was highly valued in the broader technical community. The most gratifying aspect of this recognition was its focus on technical merit rather than interpersonal dynamics. My reputation was built on the quality of my problem-solving approaches, the effectiveness of my debugging methodologies, and the business results achieved through systematic technical debt management. 3 years after leaving my former company, I was recruited for a VP of engineering position at a growing technology startup. The role required exactly the combination of technical depth and systematic thinking that I had been developing throughout my career. The startup's founders understood that building scalable, reliable systems required the kind of methodical approach to technical excellence that larger organizations often overlooked. The irony of my career trajectory wasn't lost on me. The debugging skills that had been dismissed as evidence of my inability to handle pressure had become the foundation for technical leadership responsibilities. The systematic thinking that was viewed as excessive perfectionism had proven essential for building sustainable technology organizations. The startup opportunity represented a chance to apply everything I had learned about technical debt management, system reliability, and sustainable development practices from the ground up. Rather than inheriting years of accumulated technical debt, I could establish architectural patterns and development methodologies that would prevent common categories of infrastructure problems. Building an engineering culture that valued systematic thinking and technical excellence required careful attention to hiring, training, and performance evaluation processes. I needed to recruit engineers who shared my commitment to sustainable development practices while also delivering the rapid innovation that startup environments demanded. The balance between technical excellence and business velocity required constant calibration. Unlike my former manager, I understood that sustainable rapid development was only possible with proper attention to system reliability and technical debt management. Shortcuts that created future maintenance burdens ultimately slowed development rather than accelerating it. The engineering team I built reflected this philosophy, combining deep technical expertise with pragmatic business understanding. We established development practices that maintained high code quality while delivering features quickly enough to support aggressive business growth targets. The company's success validated my approach to technical leadership. Our platform reliability was industry-leading, customer satisfaction remained high even during rapid scaling, and the engineering team maintained productivity levels that exceeded industry benchmarks. The systematic debugging and technical debt management practices that had been dismissed at my former company became core competitive advantages. Looking back on the experience with Marcus, I realized that our disagreement hadn't been about pressure handling or technical competence. It had been about fundamentally different philosophies regarding sustainable software development. He prioritized short-term feature velocity over long-term system stability, while I understood that sustainable velocity required careful attention to technical foundations. Neither approach was inherently right or wrong. They were optimized for different organizational contexts and business requirements. A startup in rapid experimentation mode might benefit from Marcus's approach, while an established company with critical infrastructure responsibilities needed the systematic thinking I provided. The professional vindication came not from proving Marcus wrong, but from finding organizational contexts where my approach to technical problem-solving was properly valued. The systematic debugging skills that seemed like excessive perfectionism in his environment were essential capabilities in roles focused on building reliable, scalable systems. The broader career lesson was about the importance of organizational fit rather than absolute technical competence. Excellent engineers can seem ineffective in environments that don't value their particular strengths, while those same engineers can achieve remarkable success in contexts that align with their technical philosophy. Marcus's assessment of my pressure handling abilities had been based on observing my work in an environment that fundamentally misunderstood the nature of sustainable software development. He interpreted my systematic approach as evidence of slowness rather than recognizing it as evidence of thoroughness and long-term thinking. The 847 bugs I resolved during those 3 months represented more than just technical fixes. They were a comprehensive audit and remediation of systemic infrastructure problems. Each ticket was an investment in long-term platform stability that would pay dividends for years. Marcus saw only the opportunity cost of not delivering new features quickly. The headhunting process that led to my current role had been initiated by engineers who understood the value of systematic technical thinking. They recognized that building reliable developer tools required exactly the kind of methodical problem-solving approach that I had been developing. The same skills that seemed like liabilities in one context became valuable assets in another. Years later, I occasionally wondered whether Marcus had learned anything from the infrastructure crisis that followed my departure. Did he recognize the connection between his development philosophy and the technical debt accumulation that eventually crippled the platform? Did he understand why the consulting engineers recommended the same systematic approaches he had dismissed? Perhaps more importantly, I wondered whether he had developed more nuanced views about the relationship between technical excellence and business velocity. The pressure he felt to deliver features quickly was real and understandable, but his solution created bigger problems than it solved. The professional vindication wasn't about proving that my approach was universally superior, but about demonstrating that systematic technical thinking was valuable in the right organizational contexts. The engineering leadership role I eventually achieved was possible because I had maintained my commitment to technical excellence, even when it wasn't immediately appreciated. The most lasting lesson was about professional resilience and the importance of understanding your own technical values. Marcus's criticism had stung initially, but it ultimately motivated me to seek environments where my systematic approach would be properly valued. The career growth that followed was built on staying true to my technical principles rather than compromising them to fit organizational expectations. Looking back, the experience taught me that professional vindication isn't about dramatic confrontations or obvious moments of triumph. It's about the sustained success that comes from applying your skills in contexts where they're valued and supported. The systematic debugging abilities that seemed like weaknesses in one environment became the foundation for technical leadership in another. The 847 bugs I fixed during those 3 months weren't just resolved tickets. They were proof points for a systematic approach to technical problem solving that would define my entire career. Each bug was an opportunity to demonstrate that sustainable software development required careful attention to technical foundations, not just rapid feature delivery. Marcus's face when he learned about my promotion to Vice President of Engineering was indeed priceless, according to mutual colleagues who witnessed his reaction. But by that point, his opinion mattered less than the recognition I had earned from engineers who understood the value of systematic technical thinking. The true vindication was professional rather than personal. It came through building engineering organizations that valued technical excellence, mentoring engineers who shared my commitment to systematic problem solving, and contributing to industry discussions about sustainable development practices. The systematic debugging skills that Marcus dismissed as evidence of poor pressure handling became the foundation for a technical leadership career focused on building reliable, scalable systems. The same methodologies that seemed like excessive perfectionism in his environment were recognized as essential expertise in organizations committed to technical excellence. The professional journey from that sterile conference room to technical leadership roles taught me that vindication isn't about proving critics wrong. It's about finding contexts where your strengths are valued and your contributions make meaningful impact. The 847 bugs were just the beginning of a career built on systematic technical thinking and sustainable development practices. Marcus had been wrong about my ability to handle pressure, but his mistake had inadvertently pushed me toward opportunities that were better aligned with my technical philosophy. The systematic approach he criticized became the defining characteristic of my professional identity and the foundation for sustained career success. The irony was complete. The debugging expertise that supposedly demonstrated my inability to work under pressure became the basis for technical leadership roles where systematic thinking under pressure was the primary job requirement. The vindication wasn't dramatic, but it was thorough, professional, and ultimately satisfying in ways that dramatic confrontations never could have been.